Hello my dear children, once again welcome to our physics class. Hope you all are fine over there. Children, in the previous session we had started our new chapter, that is ray optics, and we discussed some of the fundamentals of ray optics. Today we are going to discuss the most important derivation, that is refraction at a spherical surface. You need to remember the result of this derivation as it is useful for our further derivations. Okay children, so let's get started with today's session. Please be ready with your notebook and pen and try to do the derivation along with me. Otherwise you will get confused. Okay, so please try to do the derivation along with me and please be attentive throughout the session. Okay children. Children, so let's continue with our chapter 9, ray optics. As discussed in our introductory video, today we are going to discuss about refraction at a spherical surface and lens maker's formula. But before moving on to our point of discussion, let's be familiar with the terminologies of lenses. We had already studied about the terminologies related to lenses in our class 10 physics. So let's just go through a quick review of what we had studied in our previous classes. So this is a convex lens and this is a concave lens. Okay. Now, for any type of lens, whether it is convex or concave lens, the geometric center of the lens is known as optical center and it is denoted by O. Line passing through O is known as principal axis, and a lens has two spherical surface, convex lens. This is one surface and this is another surface. So there will be two center of curvature. So one center of curvature corresponding to this lens, that means the spherical surface on the on the right, and one center of curvature corresponding to this spherical surface on the right. Okay, we can name it as C1 or C2 like that. Then it will have two foci. So let this be our first focus and let this be our second focus. Now this C1 is also known as 2f1 in lenses. Instead of C2 we can name 2f2. And also the distance between the optic center and the center of curvature, or the 2f1, is known as radius of curvature r1. And here also the distance between the optical center and 2f2 is radius of curvature r2. And as per sign convention, all the horizontal distances to the left side of optical center is taken as negative, and all the horizontal distances to the right side of optical center is measured as positive, and all the vertical distances above the principal axis is measured as positive. All the vertical distances below the principal axis is measured as negative. Here also the vertical distances below the principal axis is measured as negative. Okay, so these are some of the terminologies and sign convention that we had already applied to study about lenses. Children, now we can discuss about refraction at spherical surfaces. So all of you can see the diagram on the screen. Using this diagram we are going to discuss about the refraction at spherical surfaces. Okay, so on the screen you can see one spherical surface NM. O is the object and two media are here. N1 is the refractive index of this medium and N2 is the refractive index of the second medium. A light ray from the object O enters from one medium of refractive index N1 to the second medium of refractive index N2. Also N1 is the rarer medium and N2 is a denser medium. So whenever light ray enters from a rarer medium to denser medium, it will bend and light ray bends towards the normal. So here, which is the normal? Can you see this dotted line? this dotted line passing through center of curvature. This line is our normal. So here the light ray from the object O enters from the medium of refractive index N1 to the second medium of refractive index N2 and undergoes a deviation, and the light ray deviates towards the normal. So this angle is the angle between normal and the incident ray. This is our angle of incidence, and this angle, which is the angle between refracted ray and the normal, is our angle of refraction. Okay, and finally the refracted ray meets the principal axis here. There you will get the image. Okay, so image is produced at this point and it is denoted by I, image. Object is denoted by O, image is denoted by I. So what is the object distance? Object distance is denoted by U. So here you can see U. U is the distance of object from the spherical surface. Okay, this distance, that is U. Similarly, the distance between image I and this spherical surface will be V. So V is the image distance. Okay. Now, what is R? R is the radius of curvature, and radius of curvature is the distance between the center of that spherical surface and the center of curvature. Okay, that means the distance between the spherical surface and the center of curvature, that is R, radius of curvature. Okay children, so this is about the diagram. Now we are going to do some mathematical expressions in order to derive a formula for refraction at spherical surfaces. Okay, so we are going to derive a relationship between U, V, R, N1 and N2. So for that, some assumptions need to be has to be made. Okay, so the first assumption is that aperture of the surface is very small. So here this is the aperture, Nm is the aperture, and this aperture is very small, assumed to be very small, so that we can consider this Mn as a straight line. Instead of a curved surface, we can consider it as a straight line because the aperture of this spherical surface is assumed to be very small. And here we need to consider some triangles. See here we need to consider some triangles. So which are the triangles? First triangle is triangle NOM. So consider the triangle NOM. This is NOM. Okay, triangle NOM. This is the triangle NOM. Triangle NOM. Now, so this is our angle NOM. Which is angle NOM? Angle NOM is this angle. And tan of that angle is opposite side by adjacent side. So opposite side is NM and adjacent side is OM. Okay, so the tan of angle NOM will be MN by OM. Okay, so that is written here, NM by OM. Now consider the second triangle. So which is the second triangle considered here? Triangle NCM. Okay, which is NCM? NCM. This is our second triangle. And here we are considering this angle, angle NCM. Angle NCM is this angle. So which is the opposite side of this angle? Opposite side is NM. And which is the adjacent side? Adjacent side is CM. Okay, so what will be tan of angle NCM? Tan of angle NCM will be opposite side by adjacent side, that is MN by MC. So that is written here. Okay, now consider another triangle, that is triangle NIM. NIM. Let this be our third triangle, triangle NIM. again here we are considering this angle NIM. Consider this angle NIM. So here, which is the opposite side? Again opposite side is NM. Which is the adjacent side? Adjacent side is IM. Isn't it? Adjacent side is IM. So tan of angle NIM will be opposite side by adjacent side. That is NM by MI. So that is written here. And again here we can do some assumptions. That means these are very small angles. So we can apply small angle approximation. And for small angle approximation, tan theta is approximately equal to theta. Similarly, sin theta is approximately equal to theta. So here we have tan of angle NOM. Since angle NOM is very small, tan of angle NOM will be approximately equal to angle NOM. Okay. Similarly, here we have tan of angle NCM. Since angle NCM is very small, tan of angle NCM is approximately equal to angle NCM. Similarly, tan of angle NIM is approximately equal to angle NIM. Okay, so these are the small angle approximation, and children, you need to remember these relations for our further derivation. Okay, so just note down this derivation. We require these expressions for further substitution. Okay children, so be ready with a pen and notebook and note down all these steps. Do the derivation along with me. Now for triangle NOC, again we are doing some other substitutions. We are considering triangles in another way. So consider the triangle NOC. Which is the triangle NOC? This is the triangle NOC. Okay. So for this triangle NOC, angle I is our exterior angle, isn't it? So for this triangle NOC, angle I lies outside the triangle, so it is the exterior angle. And you had studied geometry in maths, that is exterior angle will be equal to sum of interior angles. So here I is exterior angle, and that exterior angle I will be equal to the sum of interior angles of the triangle NOC. So for triangle NOC, this is one interior angle, this is another interior angle. So which are the two interior angles for NOC? Angle NOM and angle NCM. So our exterior angle I will be equal to sum of these two interior angles. Okay, and that is written here. Now similarly, we can find out similar relation from another triangle. That is, consider the triangle NIM. Consider this triangle, or you can also consider this triangle. Consider the triangle NIC. This triangle. Okay. Now here for this triangle, if we consider this angle will be an exterior angle for the triangle NIC, isn't it? So which is the exterior angle? Exterior angle is NCM. So angle NCM is an exterior angle for the triangle NIC. So as per geometry, that exterior angle will be equal to sum of two interior angles. So for this triangle NIC, R is one interior angle and this is another interior angle. And which is that interior angle? It is NIM. Isn't it? NIM. This angle is NIM. Okay. So which are the two interior angles? R and angle NIM. So angle NCM is the exterior angle, and that exterior angle will be equal to sum of two interior angles R and NIM. From this, what will be R? R is equal to angle NCM minus angle NIM, isn't it? So that is what is written here. R is equal to angle NCM minus angle NIM. Okay. Now here also we got the expression for I. I is angle NOM plus angle NCM that we got previously. Now just substitute the expressions for angle NOM and angle NCM. So from the previous slide we already got the expression for angle NOM. Do you remember what is angle NOM? So here you got tan of angle NOM, and tan of angle NOM is approximately equal to angle NOM. And what is that angle NOM? It is MN by OM. So here instead of angle NOM, substitute MN by OM plus angle NCM. What is angle NCM? Again, here angle NCM is equal to MN by MC. So for NCM, substitute MN by MC. So instead of angle NOM, substitute MN by OM, and instead of angle NCM, substitute MN by MC. Let this be our equation 1. So we got an expression for angle of incidence I. Similarly, here substitute for angle NCM and angle NIM from the previous slides. So for NCM we already got the expression. What is NCM? It is MN by MC. So substitute NCM is MN by MC, and NIM, angle NIM. See from the previous slides, what is angle NIM? NIM is MN by MI. So here instead of angle NIM, substitute MN by NI. So here instead of angle NIM, substitute MN by MI. So we got the expression for angle of refraction. Angle of refraction is MN by MC minus MN by MI. Let this be our equation 2. So we got expressions for angle of incidence and angle of refraction. Now we are going to substitute these expressions for angle of incidence and angle of refraction in our Snell's law. And you remember what is Snell's law? Snell's law is sin I by sin R equal to N21. So we are going to substitute this I and R in our Snell's law. So before that, you must remember these expressions for I and R. Then only we can substitute. So I is MN by OM plus MN by MC, and R is MN by MC minus MN by MI. Okay. Now what is Snell's law? N1 sin I is equal to N2 sin R. So why do this Snell's law look like this? Do you have any confusion here? We know as per Snell's law, sin I by sin R is equal to N21, and N21 can be written as N2 by N1. Just cross multiply. After cross multiplication you will get N1 sin I is equal to N2 sin R, isn't it? And again if you apply small angle approximation, we will get N1 into sin I. See, sin I is approximately equal to I when we apply the small angle approximation. So N1 sin I can be written as N1I, and here N2 sin R can be written as N2R after applying the small angle approximation. So that is written here. Now by Snell's law, N1 sin I is equal to N2 sin R. For small angles it will be N1I is equal to N2R. Now it's time to substitute for I and R. So from the previous slides we got the expression for I. What is I? I is MN by OM plus MN by MC. So substitute here. So we will get N1 into MN by OM plus MN by MC equal to N2 into, substitute the expression for R. What is the expression for R? MN by MN by MC minus MN by MI. Okay, so here I told you Mn is the common factor, so we can take mn as common factor, and since mn is present on both the sides of the equation, it will be cancelled. Mn is a like term. Then after that you will get the expression like this: n1 into 1 by om plus 1 by mc equal to n2 into 1 by mc minus 1 by mi. Okay. Now we can just rearrange the expression. So just multiply this n1 to bracket. When you multiply n1 to the bracket, you will get n1 by om plus n1 by mc equal to n2 by mc minus n2 by mi. Okay. Now bring this n2 by m1 to LHS. Minus n2 by m1, bring it to LHS. So it will become n1 by om plus n2 by mi equal to, bring this plus n1 by mc to RHS. So we will get n2 by mc minus n1 by mc. Okay, so that is written here: n1 by om plus n2 by mi equal to n2 by mc minus n1 by mc. Since denominators are common, you can directly subtract the numerator. So it is written like this: n2 minus n1 by mc. Okay, so this is the important relation. Now we are going to substitute for om, mi and mc from the figure. Okay. Now from the figure you will get om is minus u, isn't it? What is om? See, this is om and om is u, and after applying sign convention it is minus u because u is always taken as negative. So om is minus u. And similarly, what is mi? Mi is this distance v. Mi is equal to v and it is positive. MC, what is MC? MC is this distance and NC is radius of curvature r. Again it is taken as positive. So substitute the expressions for OM, MI, MC in the equation 3. Which is our equation 3? This is our equation 3. So after substituting, you will get N1 by OM is minus U plus N2 by MI is V equal to N2 minus N1 by MC is R. Okay, so after substituting, you will get this expression. So that is written here, N2 by V, here it is by not minus, N2 by V minus N1 by U. We got minus N1 by U plus N2 by V actually, and they have just written N2 by V in the beginning. So N2 by V minus N1 by U equal to N2 minus N1 by R. 2 minus N1 by R. Okay, so this is our equation 4, and this equation gives us the relationship between object and image distance in terms of refractive index of the medium and radius of curvature of the curved spherical surface. It holds for any curved spherical surface. Okay, so this is the expression for refraction at a spherical surface. First, remember this expression. It's very important expression. Okay, children. Okay, children, with this I am concluding my session. Notes of the topic have been uploaded. Please go through it. We will meet in the next session. Till then, take care all of you. Stay home, stay safe. Thank you.